Okay, so adding and subtracting radicals. Last time we looked at radicals just to refresh. The nth root of any number is simply a raised 1 over n. And as long as n is odd, a can be negative, but if n is even, a has to be positive. So if we have to add or subtract radicals, one of the key things remember is sort of factoring with radicals. Suppose we have square root of 24. Is 24 a perfect square?
No.
No, it's not. 25 is. But I can rewrite this in terms of perfect squares and sort of put out common terms. So I could write 24 as 4 times 6. Since we have a product, I could apply the radical to each term. Nothing I could do about that root 6. But what is root 4? 2. So I can write square root of 24 as 2 times root 6. Yes? But why is this important? Let's say we have a case square root of 38. Square root of 42. Is 38 a perfect square? No. Is 42 a perfect square? No. But what is in common between the two? Well, that is divisible by 2, so is 42. So I can split it up and write 38 as 2 times 90. (42), I can write it as 2 times 21. I can then split the roots and write it as square root of 2 times square root of 19. Same over here. What do I have in common now? Root 2. So if I pull root 2 out, I can write the answer as root 19 plus root 21 times root 2. It is very trivial in this case because these are numbers. You can evaluate these using the calculator. But I want you to understand the process because that's what's important when we have variables. Does that make sense? I want you to give that one a try. Let's see if you can factor it and write it a proper way. So square root of 44, I could write it as 4 times 11. And anytime we try to factor, we are looking for common terms. So the reason why I wrote 4 here, because 4 is common between 44 and 36. So eventually it is going to result in a common factor because it is a common number inside the root. So 4 times 9 going to split the root and write it as square root of 4 times square root of 11 plus square root of 4 times square root of 9. Square root of 4 is 2. Square root of 4 is 2, and square root of 9 is 3. What do we have in common between those two terms? 2. If I pull that out, I'll have square root of 11 plus 3. So we are going to use the same logic of factoring to combine these two. What do we mean when we say we're combining radicals? All we're doing is pulling out common terms and writing it in a simplified manner. So let's see. I have an x in common already, so 3 square root. I see a 12 there, I see a 12 there. So 12 is a common factor. So 12 times 4 times x minus 2 square root of 12x. Yes. And now I can split the root and apply it to each term. 3 times square root of 12 times square root of 4 times square root of x minus 2 square root of 12 times square root of x. There are multiple ways to do this, but I'm going to do it this way. Square root of 12, can I split it further? So that I have a perfect square. I can write it as square root of 4 times 3. That square root of 4 would become 2 multiplied by root x minus 2 going to write that 12 as square root of 4 times 3. What do we have in common? We have a 2 root x in both terms. If I take 2 times root x out, I will have 3. Split the root, square root of 4 times square root of 3 minus, I took 2 times root x out, square root of 4 times square root of 3. Yes? Root 4 is 2, 3 times 2, 6. So 6 root 3. Root 4 is 2 minus 2 root 3. What would that reduce to? 6 root 3 minus 2 root 3. What is it?
3 root 3.
Close.
Wait, no. 4.
4 root 3. 6 apples minus 2 apples. Right? Treat root 3 as an apple. So that will give you 4 apples, which is 4 root 3. I can now multiply the 4 and the 2. 8 root x root 3. Just like how I can split the roots, I can bump them together as long as I'm multiplying. So 8 square root of 3x. Yes? So the other way of doing it recognize that 48x can be written as 4 times 12x. Correct? What do I have in common between that? Well, before I do that, square root of 4 times square root of 12x. Yes, split it up. Minus 2 root 12x. Yes. What do I have in common? 2 square root of 12x, because I have 3 times 2 square root of 12x minus 2 square root of 12x. What is in common? Two square root of 12x. If you take that out from the first term, you will have 3. If you take that out from the second term, you will have minus 1. Yes? So 2 square root of 12x times 2. 2 times 2 is 4. Square root of 12x. So this answer and that answer are one and the same. Do you agree? So I have a 12. I can write 12 as 4 times 3. What happens when you pull 4 out of the root? It becomes 2. 4 times 2 is 8. So 8 square root of 3x. Which one you like best, that or that? This. So going to keep that 4 as is. I'm going to try and rewrite each of those numbers in terms of perfect squares, so I can simply pull them out of the root. I could write 50 as 25 times 2. There is an x, so 2x. Plus 3 square root of 2x. I can write 72x as 36 times 2x. Yes? We know 25 is 5 squared. 5 squared comes out of the root, it becomes, what happens to the root of the square? I can write 36 as 6 squared. Yes. I'm just doing an extra step so you can follow it. Split the root. Anytime I teach in this function, I talk about squigglies. So the root and the square will just cancel. Same over here, root and the square will get cancelled. What am I leaving behind? 5 times 4, 20. 20 times root 2x, 3 times root 2x, 6 times root 2x. So in total, how many root 2x's do we have? 29. Yes? So a root 48a plus 27a cubed. So first thing to do, since we see roots, we want to write it in terms of perfect squares. I want to split 48 in terms of a perfect square and a number. What are the two numbers? Could it be 12 times 4? 12 times 4 is 48, but does it have a perfect square? No. How about 16 times 3? Yes. I want to write 27 in terms of a perfect square. So what should it be? 3 and 9, so 9 times 3. Yes. A cubed, I can write it in terms of a squared. A squared times a. Yes. Going to split the root 16 times root 3a. I have 9 and a squared. Going to put it under one root and move root 3a to the other. I can do this because I'm multiplying numbers. But 9 is 3 squared, correct? I'll write it in the next one. 16 is 4 squared. 9 is 3 squared. Squiggly, the root and the square will go away. Same. What are you left with? You are left with 4a. Square root of 3a plus 3a square root of 3a. In total, how many square roots of 3a's do we have? 7a squared. 7a. So again, 4a monkeys plus 3a monkeys, 7a monkeys. But first step, to write whatever that is inside the root in terms of perfect squares. So square root of 100 times 2 times x squared times x. See, I'm splitting it in terms of perfect squares. Minus x. Well, how should we split 32 so that I get a perfect square? 16 and 2. Hundred, if you pull it out of the root, it would become Landry? 50,
I'm 10, sorry.
10. If x squared comes out of the root, it becomes x. So what do we leave behind inside the root? 2 and x. Yes? Over here, minus x. If 16 comes out of the root, it becomes 4. We leave behind 2 and x. So we end up having 10x square root of 2x minus 4x square root of 2x. 10x square root of 2x minus 4x square root of 2x is 6x square root of 2x.